In a recent video, my big track used the transporter to deliver this item to me. It's a photosensitive Firefly DIY soldering kit, and it was originally a gift from my brother. So I thought it'd be fun to assemble this kit in this video, so let's go ahead and get started. We do have some handy instructions here, although they are in Chinese. I'll do my best to understand what's going on as we assemble the kit. This looks like it's probably the body of the Firefly. Here's the PCB. Okay, so we have the body, the main PCB, a battery holder, some sticky pads, which I assume will be used to connect the body to the PCB, like so. And I believe the battery clip goes on the underside again as well, so that makes sense. We have an LED, a few transistors, and we'll check those out as we go through. We have a IC, and I think this is an LM358, but again, we will double check that when we look a little closer. These are vibration motors, and this will cause the robot to buzz along the table. A switch to turn the device on and off. Some light-sensitive resistors, which will allow the robot to determine direction to travel. A variable resistor or potentiometer to allow us to vary some aspect of the circuit. Some pin headers and a capacitor here, and this one is a bit hard to read actually. It looks like it might be 100 microfarad, 16 volt, but the casing is a little bit chopped off, so hard to tell. We can, of course, cross-reference with the instructions, where we do indeed see that we have a 100 microfarad capacitor, so that would make sense. And we do see an LM358, which is our IC. It does look like we have a couple of different transistors. We have a 9014 and two 8550, so we'll need to make sure we put those in the right way round and in the right places when we assemble the board. There's some nice silkscreen on this PCB, and as usual, I'm going to start with the resistors. Next, let's take a look at these transistors. So this one is 8550. This one is 9014. And this one is 8550. So let's take our 9014 and install that one first, followed by the 8550s. And as usual, we are just following the shape of the transistor on the PCB. Let's install this socket and make sure the notch goes to the notch on the PCB. We can put the LED in next, and this is supposed to be a Firefly, so I think I'm actually going to mount it like this by bending the leads over slightly. But we do need to make sure that we keep the polarity correct. And so the long lead is positive and the short lead is negative, and there's actually a flat side here, and as usual, an anvil as well. Now, this particular product is going to require a coin cell battery, so I do have one to hand here. And this is actually a rechargeable lithium battery, so it actually has a slightly higher voltage, but it's what I'm going to use in the project today. And so we can just validate to make sure that the shorter leg is negative by briefly touching like so, and as you can see, the LED illuminates. That should be clear because on the back of the coin cell here we have a large positive symbol here, and the other side is negative. There we go. Positive on the top and the longer lead is on the top. So we can put this in just like so. And this will let us have the back end of the LED, back end of the bug illuminate, just like a real Firefly. And we're going to put variable resistors, light dependent resistors, sorry, down here, which will represent the eyes and the direction of travel. Now let's put the actual variable resistor in. We have our 100 microfarad capacitor. As I mentioned, it's not particularly well marked. I don't know if you need the light there, but the 1 is actually missing on this because of the way the sleeve's been cut. In this case, we have the negative symbol on the sleeve, and that again is with the shorter lead, but we can match that up here. And so positive is the unshaded area and negative is the shaded area. There's actually a small positive sign here as well. Right, we also have our switch. And I don't usually crop these leads, but these ones are particularly long, so I'm going to crop these down. Now we should put in our light dependent resistors. And this is what they look like. Doesn't matter which way around these go, but you're going to want to have them face forward a little bit so that the robot can move in that relevant direction or away from that relevant direction, I suppose, depending on how it's actually configured. So we're probably going to want to fold these forward a little bit as well. So leave a little bit of length and maybe make them adjustable as well. So maybe I'll leave them a little bit long so we can tweak them after in our design. So I think what I'm going to do actually is just make sure the board is flat like this and just push them against the table. So first up, I need to make sure the leads are nice and straight. So just make sure we're happy with the length of these. I think that's pretty good. So let's go ahead and solder those second legs as well. In the design, what you would usually do is shrink these little tubes over here. I'm not going to bother shrinking them for now, but I will just keep them to hand in case I need to use them. But for the moment, I'm just going to bend these eyes a little bit forward using the tweezers like so. And hopefully that will give us a bit of direction to our Firefly. And we can, of course, adjust this more if we want to. Now, we need to fix this to here at this point, I think. And the reason being because we want to make sure things like our length for our battery holder and putting our motors in place are good. So let's go ahead and peel off the coating here. And we can use our 3M pad here to stick our robot in place. Now, we do need to bend these legs down, and so I will actually have the ability to get to these pads. And obviously, we can just about get to the terminals here as well for the power. I'm going to go ahead and solder on the relevant terminals here. So now the positive terminal here is connecting to the red wire and the negative terminal here is connecting through to the black wire. And then as we can see here, negative, negative, positive to positive. So I'm actually just going to pop this in and we're going to solder this rather unconventionally from this side. And then assuming everything's in place, we will stick it down. Okay, so there we have it. Nice little neat connection just there. Okay, so now we need to bend down these parts. And it occurs to me that I didn't take the underside film off, I don't think. There we go, much better. Okay, so just two more things to do. We have the motors to install and then our chip. So the motors have some self-adhesive pads on them as well, and they don't specify a polarity, so I'm just going to put them in the polarity that they kind of naturally fall into, and we'll see how that works. Now, because these are very fine wires, I think I'm just going to leave them long. Okay, so this wire is now attached, and we can stick it like so. But let's just install this second one. Okay, so our second motor is attached as well. So let's stick them down. And then finally we have our chip, which is our LM358. To straighten up some of these pins. And then install it with the matching notch, which should be matching the PCB trace or PCB silkscreen. And we can install our battery. So let's try turning it on and see what happens. So we do have a LED on the back, that's nice. We aren't getting any vibration though from the motors, which is interesting. So maybe we need to adjust this here. Well, that turns out the LED and that brightens it. Okay, so that's interesting. We're not getting any response on our motors. After a little bit of off-camera investigation and comparing the provided schematic diagram with the PCB, it seems that everything here is actually in order. The problem here is that the device is a little bit more sensitive than you might expect. So if I turn it on here, you can see I do actually have the LED very gently breathing. And this is because all we need to do is calibrate this resistor here very carefully so that it's doing an appropriate discharge cycle. When you get the LED turn off, that's usually a good indication that you're in the rough region, and you can see that the LED is now pulsing gently. So what about the movement from the bug's eyes? Well, the bug doesn't really move very much underneath the bright lights I have here, but I do have a torch that I can use to activate it. So if I turn the torch on, you can see this is a fairly bright torch, and if I point it directly at the bug's eyes, I can get it to move. It's the next day, and I thought I'd give you a brief update on where I got to with my light-controlled robot. The first thing I did was went ahead and looked a little more closely at this schematic diagram that was provided with the kit. If we consider the diagram, we can see there are actually three essentially independent circuits here. The first one is this on the right-hand side, which has an LM358. This circuit uses the capacitor and the variable resistor, along with this driving transistor, to control the frequency at which the LED pulses. I can go ahead and turn this on now, and we'll see the LED pulses at a nice reasonable frequency, and I can go ahead and adjust that with the variable resistor here. The other two circuits are these motor control circuits just here, and they're actually both identical. Now, despite the pictogram provided, the 8550 transistor is actually a PNP transistor. Whether or not the motor activates is controlled by the voltage divider on the base here, and by default we have a 430 ohm resistor and the light dependent resistor. The 430 ohm resistors are just here. If we look at my device now, we can see I've replaced those resistors with these 10K ones instead. And what that does is it means that we have changed the amount of light required to activate the motor. Under these studio lighting conditions here, the robot is constantly being activated by the studio lights and trying to scurry away. So I've actually put some heat shrink tubing around the variable resistors here just to shield them just a tiny bit. There was some heat shrink tubing provided with the kit for this purpose. What this means now, though, is I can actually control the robot much more easily with my torch. And as you can see, it tries to scurry away from the light. If I turn the studio lights off here, I don't actually need these shrouds, and I can have it scurry around the table quite happily. So now I've resolved the problems with activating the robot. I thought that was an interesting little update for you. So I hope you've found the assembly of this kit and the modifications I made interesting, and I hope to speak to you again soon in the next video.